This video is a short preparation for the formal definition of limit. I want to explain how to use absolute values and inequalities to think about distances, both using geometry and algebra. This will be necessary to understand the definition of limit. First, let's recall the basics of absolute value. The best way to define absolute value algebraically is by breaking it into two cases. The absolute value of a real number x is itself when it's positive, and minus itself if it's negative. We need to include 0 in one of the two cases, it doesn't matter which one. If you need to solve an equation or an inequality algebraically, normally the best way is to break it into cases by using this definition. But it's also helpful to think of absolute value geometrically. And geometrically, I'm going to say that the absolute value of x is the distance between x and 0. And more generally, if I have two real numbers x and a, the absolute value of x minus a is the distance between x and a. And finally, a couple of properties of absolute value that we know and use often. Absolute value of the product of two real numbers is the product of absolute values. That's number one. But the same is not true for the sum. Instead, inequality number 2 here is the triangular inequality that comes in handy very often. Now let's move to the most important part of the video. What do I want to do with absolute values? When we try to write a definition of limit, we often need to talk about numbers being close to each other. And the way we do that is with inequalities like this one. The absolute value of x minus a is less than delta, where all the variables are real numbers and delta is positive. My goal is to explain many equivalent ways to write this expression. First, let's interpret it. According to what I said the absolute value means geometrically, this inequality means that the distance between x and a is smaller than delta. So whenever you want to think that the distance between x and a is smaller than delta, you can equivalently write it as the absolute value of x minus a is smaller than delta. But this inequality includes an absolute value, and algebraically sometimes this is hard to handle. We can get rid of the absolute value by doing the following. Saying the absolute value of a number is smaller than delta is the same thing as saying the number is between minus delta and delta. So these two lines are entirely equivalent. But in the last one, I now have two inequalities instead of one, but the absolute value is gone. And that normally makes the algebra easier. I can also try to isolate x by adding a to all the terms. So saying that x minus a is between minus delta and delta is equivalent to saying that x is between a minus delta and a plus delta. And once I have it this way, I like to think of this picture, that x is in the interval between a minus delta and a plus delta, not including the endpoints. What do we need to remember out of all of this? This is how we are going to try to formalize what it means for numbers to be close. And every time you see one of these inequalities, you can immediately convert it to the other equivalent inequalities, or to the geometric interpretation, or to this picture. And if you're able to do that, if you're able to move back and forth between all these equivalent statements, and you understand why they're equivalent, then you are ready to learn the formal definition of limit.